What if the next conversation you had, the next helping hand you received, wasn't from a human at all, but something remarkably close? Forget science fiction. The future is unfolding right now, this week, at a speed that's frankly staggering. The gap, that once vast chasm between flesh and blood humans and silicon and steel machines, is shrinking with breathtaking velocity. We're not just talking about robots assembling cars anymore. We're talking about machines starting to feel human, displaying hints of emotion, reasoning in ways eerily similar to our own, and moving with a lifelike grace that can make you do a double take. This isn't just an incremental update, it's a paradigm shift. From AI brains learning like toddlers on hyperspeed to next-generation humanoids adapting to new situations instantly, the lines are blurring faster than anyone predicted. Giants in the field, Nvidia, Figure AI, Agility Robotics, 1X, and a whole host of rapidly innovating companies, particularly from China, are rolling out upgrades that are nothing short of revolutionary. Today, we're diving deep. We're peeling back the curtain on the cutting-edge developments making humanoid robots more like us than ever before. What's happening in labs and factories right now isn't just cool tech. It's potentially altering the very definition of what it means to interact, to work, and maybe even to connect. Buckle up, because the world of AI and robotics just got a whole lot more real, and it might change everything you thought you knew. Let's get into it. Let's start with movement, arguably one of the most complex and subtle aspects of being human. We don't just walk, we sway, we adjust, we carry momentum. It's a constant, almost unconscious ballet of balance and coordination. For robots, replicating this has been a monumental hurdle. Think about those early prototypes, stiff, slow, almost comically awkward. Well, the American company Figure AI just blew past that limitation with their Figure 2 humanoid. They've poured resources into refining their universal control system, Helix. Now, Helix isn't just about teaching robots new skills quickly, which, by the way, Figure robots can already do, handling unfamiliar objects, tidying kitchens, sorting packages like seasoned pros. No, the big news is movement. Using a technique called reinforcement learning, engineers essentially let the AI figure out how to walk better entirely within a computer simulation. Imagine countless virtual robots trying, failing, adjusting, and learning from millions of iterations, far faster than any physical training could allow. The truly mind-blowing part: they took this fully trained neural network, this AI brain honed in the digital realm, and plugged it straight into the real-world Figure 2 robots. No extra tweaking, no retraining needed. The result? A robot that walks faster, more stably, and with a gait that's noticeably, almost unsettlingly, human-like. It's not just about getting from A to B anymore, it's about how it gets there. This breakthrough isn't just cosmetic. It opens doors for robots operating in human environments, navigating uneven terrain, maybe even eventually keeping pace with us on a busy sidewalk. Think about disaster zones, construction sites, or even just navigating a cluttered home. Smooth, adaptive movement is key. Figure AI just took a giant leap in that direction. While Figure focuses on fundamental movement and industrial tasks, other companies are zeroing in on putting robots directly into customer-facing roles. Enter Robotics from China with their X-Man R1. This humanoid isn't designed for the factory floor. It's built for the hustle and bustle of the service industry: hotels, restaurants, shops, public spaces. Imagine checking into a hotel and having R1 deliver your luggage, or dining out and having it serve your food and drinks. It's not just delivery, though. Keenan envisions R1 as an active assistant, helping human staff attend to guests, answering questions, and providing directions using built-in navigation and obstacle avoidance. But it gets even more practical. R1 can also handle waste collection and even clean restrooms. That's right, maintaining public cleanliness could soon be a task for our robotic counterparts. How does it do all this? Sensors, smart navigation algorithms, facial recognition to potentially personalize interactions, and voice command understanding. It can even pour beverages. This isn't just about replacing human jobs. It's about enhancing the customer experience, providing consistent service, handling mundane tasks, and freeing up human staff for more complex, nuanced interactions. Could you imagine ordering a coffee from a robot that recognizes you and remembers your usual order? Keenan is betting on that future. Now, let's shift gears to an area that often pushes the boundaries of comfort and technology: hyperrealism. The developer IronTech Doll, known for its realistic robotic companions, recently gave a glimpse inside its factory. Their video showcases the meticulous process behind their Real Lady series, premium, high-quality silicone robots designed for the closest possible resemblance to the human form. We're talking detailed modeling, casting, intricate assembly, and hand painting to achieve maximum realism. A key feature is their one-to-one scale technology, aiming for exact replicas of the human body. High-quality silicone mimics the look and feel of natural skin, while an internal metal skeleton allows these figures to hold various poses, simulating human movement. While the primary market for these robots is specific, the underlying technology is fascinating. The relentless pursuit of realism in materials science, mechanical articulation, and detailed craftsmanship has implications far beyond this niche. The techniques used to create lifelike skin, realistic facial expressions, and articulated joints could eventually find their way into other applications. Advanced prosthetics, incredibly realistic animatronics for entertainment, or even highly specialized training mannequins for medical professionals. It highlights how diverse the field of robotics is, pushing limits in directions we might not always anticipate. Back in the industrial sphere, the race to integrate humanoids into manufacturing is heating up globally. Following the American lead, Chinese engineers from LimX Robotics have showcased their humanoid robot, Qiaofu, working at the FAW Hanke facility, a major Chinese automobile manufacturer. Qiaofu is a full-size humanoid designed for versatility, industrial manufacturing, commercial services, even scientific research. Seeing it deployed on a real production floor at FAW Hanke isn't just a demo, it's proof of practical application. This robot can navigate different surfaces, adapting as needed. Its high-precision manipulators aren't just clumsy grippers. They can perform complex tasks like assembling components or handling delicate tools. What makes this integration truly powerful is the built-in AI. Qiaofu isn't just executing pre-programmed routines. It can learn new tasks and adapt to changing conditions on the factory floor. Imagine a production line needs reconfiguring. Instead of extensive reprogramming, the robot could potentially learn the new workflow. This introduction at FAW Hanke signals a major trend: humanoid robots moving from R&D labs into the heart of manufacturing, aiming to optimize processes, boost efficiency, and potentially fill gaps in the workforce. It's about making factories smarter, more flexible, and more productive. But robots aren't just destined for factories or service roles. Their potential is expanding into incredibly creative fields. A stunning collaboration between WPP, Boston Dynamics, and Canon recently put the new generation Atlas robot in a completely unexpected role: camera operator. Think about the challenges of high-end video production. Achieving smooth, dynamic shots often requires complex rigs, skilled operators, and meticulous planning. In this demonstration, Atlas, known for its incredible agility and balance, held a professional Canon cinema camera mounted on a DJI Ronin stabilizer. The result: flawlessly smooth and precise movements, completely free of shakes or abrupt jerks, even while the robot moved confidently around the set. Atlas wasn't just holding the camera, it was performing cinematography. It maintained specific heights and positions, automatically adjusted its balance, and executed complex, pre-programmed shooting trajectories, gliding around subjects, tracking movement, creating sweeping panoramic shots. This isn't just a gimmick. It showcases how advanced robotics could revolutionize content creation. Imagine perfectly repeatable complex shots, cameras operating in environments unsafe for humans, or entirely new types of dynamic visuals only achievable through robotic precision and agility. The film set might be the next frontier for advanced humanoid capabilities. China's ambition in the humanoid space is undeniable, and Magic Lab recently laid out a bold strategy leading up to 2025. They introduced their humanoid robot, Ziohai, and a fascinating quadruped project, Gion 1. But the big announcement was their 1,000 Scenarios initiative. Their goal: to forge partnerships and integrate humanoid robots into 1,000 distinct practical applications within the next few years, ultimately aiming to make them available for home use in just 5 years. That's an incredibly aggressive timeline. The technological heart of Magic Lab's creations is the Adam Wang-Xing Universal Model. This AI brain uses a clever dual-mode fast-slow architecture. Think of it like this. The fast module handles immediate reactions, dodging an obstacle, adjusting balance instantly. The slow module tackles the bigger picture, analyzing complex tasks, planning long-term actions, understanding context using multimodal inputs, vision, sound, etc. Thanks to this system, Ziohai is already proving remarkably versatile. During demonstrations equipped with ultrasonic sensors, LiDAR, and RGBD cameras, which perceive depth, Ziohai acted as a salesperson, presenter, hairdresser, service staff member, and even a traffic controller. It took orders, consulted with customers, navigated crowded spaces, and transported objects with its grippers. This multi-skilled approach, driven by their dual-mode AI, is key to achieving that ambitious 1,000 Scenarios goal, aiming for robots that aren't just specialists but adaptable generalists. Building on this theme of service and assistance, Pudu Robotics, another Chinese innovator, unveiled a semi-humanoid robot called Flashbot Arm. Designed for environments like hotels, offices, restaurants, shops, and hospitals, Flashbot Arm features a high-precision manipulator, essentially a sophisticated robotic arm mounted on a mobile base. This arm allows it to do more than just deliver items. It can interact with customers, clean spaces, and even disinfect surfaces, a particularly relevant skill in today's world. Like other service robots, it navigates safely, uses elevators autonomously, recognizes obstacles, and adapts using AI. What sets it apart are its two manipulators, each boasting 7 degrees of freedom, meaning highly flexible joints, and a reach of up to 2 meters. This dexterity allows it to handle a wider range of tasks, delivering food and drinks precisely, handling documents, greeting visitors, assisting with navigation, and answering questions. Users can interact via voice, gestures, and even facial expressions. It's another step towards robots becoming truly integrated assistants in our daily environments. Magic Lab's presentation also highlighted a particularly inspiring application: the Gion 1 quadruped robot, specifically designed to assist visually impaired individuals. This goes beyond simple navigation. Gion 1 aims to combine movement assistance with visual and voice interaction. Imagine a visually impaired person using the robot to help select products in a store, reading labels or identifying items, or using it to order a taxi or make payments for services. The project plans to leverage the multimodal interactive capabilities of quadruped robots. Their stability, ability to traverse varied terrain, and capacity to carry sensors and communication devices to genuinely facilitate movement and improve the quality of life for people with visual impairments. This is part of Magic Lab's broader strategy for 2025, focusing on embodied intelligence, AI that exists and interacts within the physical world, and applying it to provide meaningful assistance to those with special needs. It's a powerful reminder of the positive societal impact this technology can have. The future of automation is arriving rapidly, especially in China. UBTCH Robotics demonstrated a vision of fully automated electric vehicle charging stations. Here, it's not just the car being charged automatically. The robots charge each other as needed, ensuring continuous operation. Their industrial humanoid, Walker S1, is already undergoing training in factories, including at a BYD automotive facility. Standing 172 cm tall and weighing 76 kg, Walker S1 is built for industrial tasks, carrying boxes, tightening screws, assembling components, sorting parts. UBTCH highlights a significant statistic. Currently, about 70% of automated production tasks are handled by traditional robotic manipulators, fixed arms. They plan to use humanoid robots like Walker S1 to automate an additional 20% of processes. This leaves only 10% of tasks for humans, primarily focused on coordination and tool management. In regions facing skilled labor shortages, this level of automation is seen as crucial. Humanoid robots offer the potential to reduce reliance on human labor in manufacturing, increase consistency, and operate 24/7. It paints a picture of future factories where humans and humanoids work side by side, with robots handling the bulk of the physical execution. Agility and dynamic movement continue to be key areas of development. Westwood Robotics announced an updated version of its full-size humanoid Themis version 2. While details on the new version are emerging, the previous Themis model already set a high bar. It could walk at human speed and even run up to 10 km/h. More impressively, it could perform complex dynamic movements like parkour. Successfully executing parkour, running, jumping, vaulting over obstacles, requires incredible balance, coordination, and rapid adaptation, representing a significant leap in humanoid capabilities. Westwood emphasizes that Themis V2 will integrate cutting-edge technologies focused on enhancing human-robot interaction across various fields: manufacturing, healthcare, service sectors. Advanced sensors and control systems are crucial for ensuring safe operation around people. The ability to perform dynamic, precise movements while remaining safe in shared spaces makes robots like Themis promising solutions for tasks requiring flexibility and adaptability, beyond simple, repetitive motions. Imagine a robot assistant in a hospital needing to navigate quickly and safely through busy corridors. Bringing the robot's capabilities directly under human control from afar is another exciting frontier. China's Astrobot recently demonstrated the telepresence features of its Astrobot S1 humanoid. This robot can perform various household tasks, cooking, like making waffles, cleaning, interacting with pets, either autonomously or via remote control using a virtual reality (VR) headset. Putting on the headset, a user can essentially become the robot, seeing what it sees and directing its actions in real time. The S1 is equipped with 2 highly dexterous manipulators, each with 7 degrees of freedom, enabling precise and smooth movements. Its arms can move incredibly fast, up to 10 ms, and lift objects up to 10 kg. Demonstration videos show it performing tasks requiring remarkable care and accuracy, pouring tea without spilling, feeding a cat gently. Advanced sensors and computer vision allow it to understand its surroundings and interact safely. Telepresence like this has huge potential. Experts performing complex tasks remotely. Imagine a surgeon guiding a robot miles away. People with mobility issues interacting more fully with their environment, or even just checking in on your home and pets in a much more interactive way. Replicating the dexterity of the human hand remains one of robotics' greatest challenges. Unitree Robotics, also known for its agile robots, unveiled a dedicated 5-fingered manipulator, Dex 5. This robotic hand is explicitly designed for tasks requiring high precision and dexterity, closely mimicking human capabilities. Each finger has multiple active joints, degrees of freedom, allowing for intricate movements and grasping various objects. Crucially, it's packed with tactile sensors. These sensors detect force and contact points, allowing for delicate manipulation, knowing exactly how hard it's gripping an egg versus a metal tool. Dex 5 can be integrated with Unitree's other robots, like the G1 or H1 humanoids, significantly expanding their functionality. As seen in DMOS, this kind of advanced manipulator is key for applications requiring fine motor skills, intricate assembly, laboratory work, potentially even tasks requiring a human touch. Similarly, Sciasun Dynamics introduced its Artist Light robotic arm. Like Dex 5, it aims for high precision and flexibility, mirroring human arm and hand movements. Using lightweight yet durable materials and an innovative control system, Artist Light allows for accurate operation. It can perform delicate manipulations, carefully grasping and moving objects of varying shapes and fragility. An intuitive interface and programmability make it suitable for a wide range of tasks, from simple pick and place to complex operations demanding extreme precision. Both Dex 5 and Artist Light underscore the intense focus on replicating not just human form, but human dexterity. At the recent ZGC 2025 forum in China, a major event for AI and robotics, Gallet Robotics showcased its Gallet G1 robot demonstrating practical service applications. During the demo, G1 served drinks, carefully packed goods into boxes, and sorted products in a warehouse, tasks typically performed by humans in retail and logistics. Gallet G1 is a humanoid robot built on a wheeled platform, designed specifically for service, logistics, and retail environments. It cleverly combines two types of gripping devices, traditional mechanical manipulators and vacuum suction cups. This allows it to handle a wider variety of objects, including fragile items that might be difficult for purely mechanical grippers. Standing 173 cm tall and weighing 85 kg, G1 can operate autonomously for up to 10 hours. This combination of humanoid upper body dexterity with the stability and efficiency of a wheeled base makes it a practical solution for replacing routine human labor in specific commercial settings. Unitree Robotics wasn't content with just showing off dexterity. They pushed the boundaries of humanoid agility with their G1 robot. They recently showcased the G1 becoming the first humanoid robot in the world to perform a kip-up, that acrobatic move where you spring from lying on your back to standing in one fluid motion. Seeing the G1 execute this with precision and balance in the released video is genuinely impressive and highlights the incredible advancements in control systems and dynamics. But they didn't stop there. The video also showed G1 performing flowing Tai Chi-inspired movements in sync with a human, demonstrating coordination and grace. It also showcased its ability to rapidly recover its balance after being pushed, mimicking human reflexes almost perfectly. Unitree emphasized this was all real-time footage, no speed adjustments or CGI tricks. And to top it off, G1 also became the first humanoid to master a side flip while maintaining perfect balance. These aren't just flashy stunts. They demonstrate a mastery of balance, power, and control systems that are fundamental to robots operating effectively and safely in complex, unpredictable human environments. Controlling these increasingly complex robots intuitively is another challenge. Elephant Robotics addressed this with their MyCobot arm controller S570. This isn't a joystick or a keyboard. It's a portable exoskeletal controller. You strap it onto your own arm, and it captures your movements in real time, transmitting them to a connected robotic system. The key here is the level of detail it captures. Not just your hand position, but wrist orientation, elbow bend, and even individual finger movements. Built-in sensors enable highly complex manipulations, remotely controlling a robotic arm to grasp objects, perform delicate tasks, or even using your own movements to model actions for machine learning systems to replicate later. With USB, Bluetooth, and wireless connectivity, and a lightweight design, under 800 G per arm, it offers a highly intuitive way to bridge the gap between human intention and robotic action, especially for intricate tasks. We saw UBTECH's vision for automated EV charging, and now it's becoming reality. The first fully robot-operated gas station has opened in Zhengzhou, Henan Province, China. Developed by CNPC, China National Petroleum Corporation, and GAC Motor Power Company Limited, this robot uses advanced AI and machine vision. It automatically identifies the car's fuel tank location, opens the cap, inserts the nozzle, completes refueling, retracts the nozzle, and closes the cap. The whole process takes about 2 minutes, initiated by the driver via a mobile app. You don't even need to get out of your car. This significantly boosts efficiency, cuts down waiting times, and minimizes risks associated with human error or exposure to fumes. It's a tangible example of how sophisticated robotics is starting to automate everyday conveniences. Even the world of entertainment is getting a robotic upgrade. Disney unveiled an enclosure featuring its latest BDX droids, destined for the expanded Star Wars Galaxy's Edge experience at Walt Disney World. These aren't static props, they are free-roaming, interactive characters. Recognizing the challenging Florida environment, Disney Imagineers specifically upgraded these droids for durability. Original 3D printed parts were replaced with sturdier milled components to withstand heat and humidity. Their ability to navigate uneven park terrain was also enhanced. Weighing about 20 kg, these droids use advanced tech to learn, adapt, and interact. They can even express emotions, jumping with joy for a compliment or showing displeasure when it's time to leave the stage. It's a fascinating blend of robotics, AI, and storytelling, designed to create immersive and magical experiences for park guests, requiring robots that are not just functional but also robust and engaging. The sheer scale and pace of innovation were on full display at the recent AI Robotics Expo 2025 in Shanghai. This wasn't just another tech conference. It was one of the largest global gatherings for the industry, attracting over 100,000 visitors, engineers, entrepreneurs, investors, government officials, all focused on the future of AI and robotics. The expo clearly highlighted China's dominant position in the field. Companies like Unitree Robotics, Huawei, and DJI showcased cutting-edge products, reinforcing the country's technological leadership. From advanced robotic machines and drones to humanoid systems and industrial AI, the potential to revolutionize daily life was palpable. However, it wasn't solely a Chinese showcase. Major international players were also present, vying to stay competitive. Boston Dynamics, US, presented an updated spot robot adapted for extreme conditions. ABB, Switzerland, introduced collaborative robots designed to work safely alongside humans on production lines. Nvidia, US, highlighted new machine learning platforms specifically for integrating AI into robotic systems. Adding to the industrial focus, Chinese company Sci-fi Robotics introduced their wheeled humanoid. This design makes a practical trade-off, combining a human-like upper body with 26 degrees of freedom for manipulation with the stability, efficiency, and potentially lower cost of a wheeled base. Ideal for large industrial or warehouse environments, it can transport heavy loads more easily than many bipedal designs and uses 8 sensors for comprehensive obstacle detection in dynamic settings. The Expo and robots like Sciasons painted a clear picture, a diverse, rapidly evolving global industry pushing boundaries on multiple fronts, with practical application becoming increasingly common. We saw Figure AI improving walking at the start, and they've continued to make strides, particularly in real-world application. A new video showcased their Figure 2 humanoid integrated into BMW's manufacturing facilities. The robot, standing about 168 cm tall and weighing 70 kg, demonstrated performing various automotive production tasks with improved speed and precision. Its 5-fingered hands, 16 degrees of freedom each, can manipulate objects up to 25 kg. 6 RGB cameras feed into a language-based visual perception model, allowing it to understand its environment. Critically, a custom AI model, developed with OpenAI, enables the robot to understand natural language commands and even hold conversations with human workers. This partnership with BMW, initiated in January 2024, and seeing deployment in August 2024 at BMW's South Carolina plant, involves tasks like precisely placing metal components into assembly fixtures. These collaborations are vital, proving the viability and value of humanoid robots in complex, high-stakes manufacturing environments, enhancing both efficiency and accuracy. So what does all this mean? What we're witnessing isn't just a series of isolated upgrades. It's a convergence, a turning point. AI humanoid robots are evolving at a rate that feels exponential, moving from laboratory curiosities to practical tools, assistants, and even entertainers, far faster than most predicted. The advancements in movement, dexterity, AI learning, and human-robot interaction are collectively pushing us towards a future where the presence of sophisticated robots is not the exception, but the norm. This isn't science fiction anymore. It's engineering reality unfolding before our eyes. And honestly, this is likely just the beginning. With each breakthrough, these machines get smarter, more capable, more adaptable, and yes, more human-like. The lesson here isn't necessarily about fearing a robotic takeover, but about awareness and adaptation. This technology holds immense potential to assist the elderly and disabled, to take over dangerous and repetitive jobs, to boost productivity, unlock new creative possibilities, and perhaps even help us explore environments we can't reach ourselves. But it also raises profound questions about the future of work, ethics, and our own identity. My advice: stay curious. Don't shy away from understanding these developments. Think critically about how this technology could impact your life, your community, your job. How can we best harness this power for collective good? How do we prepare ourselves and future generations for a world increasingly shared with intelligent machines? Things are moving incredibly fast in this space. What seems cutting edge today might be standard tomorrow. What are your thoughts? Which of these robotic advancements excites or concerns you the most? Where do you realistically see humanoid robots making the biggest impact in the next 5 years? Let me know in the comments below. Thanks for diving deep with us today. Stay safe, stay healthy, and keep questioning the future. And hey, if you found this journey into the world of humanoid robotics fascinating and want to stay updated on the relentless pace of AI and tech breakthroughs, make sure to hit that subscribe button and turn on notifications. You won't want to miss what's coming next. See you in the next update.